So now this question gives me a little bit more to do in terms of interpreting what I figure out. It says, what would the slope of a line be that's perpendicular to this line? This is where this is going to come into play mostly for what you are going to do. We're going to have to create equations of lines, and quite often the equations of those lines are going to need to be parallel and perpendicular. So we got to solve this thing for y in order to know what the slope of the line that I have sitting in front of me is. So I add the 5x, I divide everything by -10, and I should get y equals, that's a negative over a negative, which is a positive. You can reduce that if you want to. This is a positive over a negative, so that's a negative. And then 5/10, and again, you can reduce that if you want to, but there's no there's no necessary requirement that you have to reduce that for any of this stuff. So -5/10, that is the slope. So I'm going to write m equals -5/10. It wanted perpendicular. Let's just review what both of these things are. Parallel lines, so there's the symbol for parallel, so usually write parallel m is exactly the same, -5/10. And then perpendicular, that's the symbol for perpendicular. Perpendicular slopes is flip the fraction over and change the sign of the fraction, all right, not the numbers, the fraction. So this fraction right here, original fraction, is negative. This new fraction needs to be positive, which it is. So the perpendicular slope is right there, okay? And that's really what we're going to use this stuff for as we move into problems that we're going to have to solve.